Okay, for this air resistance bundle, the first thing you're going to be doing is a lab, and it's looking at the drag force on things when they're falling. So, for instance, looking at these people when they fall through the air, what would happen if all of a sudden they were to release their parachute? Would the drag be on them? Would the drag force on them be the same as if they didn't release their parachute? Um, what else do you think? Um, if we're looking at the velocity that this person is falling, besides the drag force being different at different speeds, what else would be different? And that's kind of what we're looking at in this lab. And the two things that I want you to check out is figure out the relationship between the terminal speed, I'm calling that VT, and the drag force. That's the one. And then the other relationship is the relationship between the terminal speed and the area. And normally when we do this lab in class, we use coffee filters. And so that's what we're looking at here, but I videotaped it and you're going to analyze the videos. So here's the URL, and type that in. Maybe. And we can download at this spot. We can download both the tracker files, and we can download the videos. So make sure you download all of them. Okay, and then once you've downloaded those, then what you can do is you can actually open them up and analyze it. So for this lab, at the very end, you're going to need a free body diagram for the falling object. In fact, I would actually do that probably first so you can really understand the drag force. And there's a spot right here for you to draw that. Every one of those coffee filters that you momentarily saw a second ago when they were falling, they were actually at their terminal velocity already. So what that means is they're not accelerating. So if they're not accelerating, you should be able to draw a free body because you know some forces that act on them, or at least one force is weight. Well, if that was the only force, then it would keep on accelerating. So there must be some other force, and we're calling that the drag force. Further, you should be able to figure out what that drag force is equal to since it's not accelerating. Okay. Once you understand that, then this lab becomes pretty easy. So now we're going to go ahead and open up the videos and start analyzing them. Okay. All right, so here's my two tracker files. This is velocity versus the air resistance or the drag force. And this one is velocity versus area. I'm going to go ahead and do the drag force one first. And it will call up the appropriate video. It's already kind of set up for you to analyze. Okay, for every one of these coffee filters you're going to be looking at, they're going to have the exact same area. So the area is constant. The only thing we're changing is we're changing the weight of them. So for the very first one, there's going to be 6 coffee filters that are kind of stacked on top of one another. And so we can see the mass of it is 5.4 plus or minus 0.2 grams. The next one that you're going to see fall is 4 coffee filters, and that's 3.6 plus or minus zero point 0.1 grams, and then so on. They all have the same area though. Okay, so what we need to do is we need to analyze this. So I'm going to click on the 6 coffee filter one. That's going to be the red dot. And it's already highlighted the first one. So I can click on it again. And I'm just going to keep on clicking on it. And from this, I will be able to figure out what the velocity of that coffee filter is. Okay, so I got that one. I need to back up here. Now I need to choose the 4 coffee filter one. I'll leave that one off. And I need to back up here so I can do the other one, the 3 coffee filter one. So I'm going to click the 3 coffee filter one. Okay, I'm going to back up because there's some here I missed. And this is the 2 coffee filter one. Okay, and now I'm going to do the 1 coffee filter one. There it is. Okay, now I have all that data, and I can come up here and choose whichever one I'm looking at. So let's say the 6 coffee filter one, and I can figure out what the average velocity is. And the way to do that is just simply select all of these, and I can import that into a spreadsheet, and I can find the average velocity. Let's say then I want to figure out for the 4 coffee filter one, I can average these and figure out what the velocity is. 3 coffee filter one, 2 coffee filter one, and finally the 1 coffee filter. We can also look at the graphs to see that, make sure they're fairly constant. And so then I can go ahead and plot my velocity versus the force. Now, the force should be equal to the weight in newtons of each one of these sets of coffee filters. So if I know it's 5.4 grams, I can figure out how many newtons that is. Have to change it to kilograms and then into newtons. And I can plot that velocity versus the force and then linearize if needed. Okay, so that's the one with the constant area. Now let's look at the next sets of information. Okay, so this is velocity versus area. Okay, for this one, in this case, the mass is going to be constant for every one of these. So the mass for every single one of these is going to be 1.8 plus or minus 0.02 grams. The thing that's changing here is the area. So for instance, here we have the small diameter. Diameter is given in centimeters. Here's medium, here's large, and here's extra large. So these are all circular. If you know the diameter, you should be able to figure out what the area is in square meters. So I'll go ahead and choose the small diameter one, and you can see it's already coming down here. And so I'll click this and follow this on down. Okay, and then I'll just simply do the next one. And there it is. And I'll just have to select this and keep on doing all of these. And so here's the first one, the small diameter. And notice here are the velocities, and so I can import those into a spreadsheet and I can average them. And I can do that with the other ones as well and find out all those velocities. And for this, I'm going to be plotting the velocity versus the area in square meters, and I can linearize if needed. Okay, and then after that you'll be able to figure out what your mathematical model is for both of them. So let's go back to that lab. Okay, so we'll be able to figure out the mathematical models for both of them. I would like the data tables, all that kind of stuff attached, graphical models, mathematical models. But the joint model, we're going to have an equation for the velocity, the speed, terminal speed versus the air resistance, and the terminal speed versus area. And you should be able to combine those into one joint mathematical model. And then finally down here at the bottom there's a couple problems to solve based upon the mathematical model that you find.